Okay, so I want to start jumping in now onto our first more in-depth example. Let's change this to black. A more in-depth example. And I want to start drawing some geometry. So let's look at slides, where are we? Slide 7. This is what I want to do. Where are we? Okay, so I'm going to draw our first shapes, and we're going to use triangles. Triangles are very popular in graphics for a lot of really cool reasons that we'll revisit again and again later. But I want to draw these two things here. First, I want to draw a blue triangle, and see the coordinates here. That's x comma y. Let's see if I can change this to a better pointer. Yeah, that's x comma y, x comma y, x comma y, and the color is blue. Red, green, blue. Okay, so I want to draw these triangles, these shapes. The first thing that should strike you is these seem like strange coordinates. In processing, we're like 200, 150. Here, I'm at 0, 1.35. They're floating points. Okay, we'll revisit that shortly. But these are the coordinates I'm going to use for blue. And a red triangle has different coordinates. And notice the color is red, green, blue. 100% red, no green, and no blue. So solid red, solid blue. And here are my coordinates. In this situation here, here's my origin. Bam, right? X, this is 0, 0 is here. X goes this way, and Y goes that way. So let's start looking at how I might draw that in my code. So the first thing I'm going to do is I'm going to use an OpenGL command called begin shapes. And this tells OpenGL, remember it's stateful, so I have to tell the video card. This tells OpenGL that I'm going to start giving it data towards shapes. And so I need to tell it what kind of shapes. So I'm going to give it triangles. Okay, this is an OpenGL command. I'm saying, hey, look, OpenGL, begin shapes. Get ready to accept some shapes. I'm going to give you some triangles. But of course, I probably want to turn this to blue. Of course, I'm not going to give it a triangle right away. First, I want to tell it what color I want to use. So I'm going to tell it, use the command fill. Looks like processing, right? That's great. I'm going to fill, I'm having trouble with this today. I'm going to fill 0, 0, and then 255. Now, oops, this should be familiar now. Red, green, and blue. And why is it 255? Because it's 8 bits per channel. It's 24-bit color. So I set the color to red, green, blue. And then now that my color is set, I make some vertices. So I go vertex. I give it an x coordinate, 0.5, what should be a minus 0.5. And then 0.3, which is what I had on my slide. I give it another vertex, which is 0.0, and then 1.0, x comma y. I give it another vertex of 0.3, 5, 0.1. Okay, so I tell it start some shapes, begin apes apparently. Let's fix that. So I give it some shape. I tell it this. I'm going to give you some data, OpenGL, and it's going to be for triangles. So I start my shapes. I set a fill color, and I send it 3 vertices. How many vertices are in a triangle? 3. That's one whole triangle. So now I can oh boy, I don't know what's going on. This data, it's going to start drawing on my screen for me. So I'm going to have this green triangle, blue triangle. The first vertex is minus 0.5, so it's going to be here, let's say. If my origin is over here somewhere, let's go to back. My origin is here somewhere. This is my 0, 0 origin. And then this is going to be minus 0.5x, right? Because you can see we're just behind there. On the left of the origin, and then y is 0.3. So I'm left of the origin that way. Oh, I'm mirrored that way of the origin, and then up. So that's my coordinate, and then my next coordinate is 0, 0. So x is at 0, and then y is up 1. So it's going to be up here, right above my origin. That's great. and then my next coordinate is going to be x of 0.35, so a little to the right, and a y of 0.1, so just above the origin, just like that. And it's a triangle, so, and I've set it to blue, so it'll fill it in just like that for me. And I can just finish this up. This is 0, 1, and this is 0.35, 0.1. Cool. Now, because I said triangle, there's an S there, oops, I can keep going, actually. I can just keep giving it more vertices if I want to. I can just go more vertex. And what happens is, because it expects triangles to come in sets of 3, yeah, that's what I do. Every 3 triangles, sets of 3. You know, for each triangle. It'll keep rendering them for me. Okay, and then when I'm done, I tell OpenGL, boy, I'm done with them triangles. I end shape. Like that. Bam. So this is my first OpenGL, right? I can put a fill command here, as you saw. Oops, let's undo that. I want it to be blue. I can put a fill command there, and I can put a fill command after each triangle if I want to. Fill commands to set color, right? So I have fill commands, I set the color, bam. Now the key to remember here, though, is that OpenGL is stateful, and I've talked about that a little bit, but here it comes up. OpenGL is stateful. It remembers. Okay? If I set my color and I don't set it, it's going to remember that color until the end of time. Okay? So keep that in mind. The other thing I want to mention here, and we'll bring this up again a little bit later, that this comes from a common pattern in graphics, this coordinate system. The fact that I'm going between 1 and -1, it was trying to keep 0 at the middle. This is really common in graphics. So in graphics, coordinates, and sometimes colors, are often standardized to -1 to 1. To plus or minus 1, so like -1 to 1. That looks like another minus. Let's fix that. Okay, and then we scale up as needed. And that might seem a little crazy because we have pixels, not half pixels, but you'll see why a little later why that doesn't matter. And keeping things between -1 and 1, it's like a standard. This will keep coming up again. People like things to be, you know, within an expected or standardized range. So I'm going to go look at some slides for a second to look at this. Let's look at slides 8, 9, and 10. All right. So this is what OpenGL looks like in processing. It's basically what I wrote in my slide, on my notes rather. I got tired, so I stopped. But you can change the fill color here, red, green, blue, right? That's full red, 8-bit channel. So it's 100% red, 0% green, 0% blue, 3 new vertices, and my shape. I can put 2 shapes in here, right into, I can put, where's that? I can put 2 shapes right in the same begin shapes, triangles. I can put as many as I want. Okay. I want to show this. This is it in C. Okay. This is processing, begin, shape, fill, vertex, and I have these standardized. The colors are within 8-bit. This is it in C. Color 001, like I said, it'd be like the standardized to 1. 100% red, 0%, 0%. It's the same thing as the processing 8-bit version of 255 using integers. This command looks slightly different. We tell it we're giving it 3 floats or 2 floats, whereas in processing you don't. GL for OpenGL, but it's the same stuff. This is C. If you have your context set up and your library is working, the OpenGL looks the same. Once you know OpenGL, it'll work in any language. And in plain old Java, instead of using GL begin, we use an object model, GL begin, and use some data. Same thing, use the floating point version, the standardized to 1 version of the color instead of the 255. But it's the same stuff. So I like to show that. This is Java, this is C, this is processing, C, Java. Small nuanced differences like the names of your constants, but it just doesn't matter, okay? It comes down to being the same old stuff. All right, so the next thing I want to talk about is viewports. And I did mention these previously in a previous class, but now we'll get into a little bit more, and now hopefully it'll make more sense. So a viewport is a drawable region. Let's see if I can make that a little neater. Drawable region on the display. So it turns out you can't just draw anywhere you want on the screen. The computer gives you a viewport that you're allowed to draw in. This could be the whole display. If you're lucky, this could be full screen. However, it could also be in a window, or just some region within the window, drawable region. Okay, so you might be given a viewport anywhere on the display, anywhere in the window. You don't have a clue, but these are called viewports. Each viewport, they have their own coordinate system. They have their own, we call it a local coordinate system. Okay, and this doesn't, that means like where the origin is and how big your scale, how many pixels, X and Y, that all changes depending on your viewport. It doesn't have to be, that should be an N, it doesn't have to be screen relative. Okay, and what that means is, it doesn't matter if your window is in the top of the screen or the bottom of the screen. Okay, your window can be the top right corner or the bottom corner, it doesn't matter. You have your local virtual coordinate system. This is often called a window coordinate system. And as I just said, these are completely virtual. They're made up. And there's a lot of reasons for this. They can map to pixels. They may map 1-to-1 to pixels. And what that means is, like in processing, right? When I go 100 by 100 as a coordinate, it's 100 pixels by 100 pixels in the window. That's possible, but it might not be, okay? So it could be completely virtual for any number of reasons. Convention, familiarity, religion, right? People have strong opinions about these things, and it doesn't really matter. So let's take a look at some slides. Is this gonna work? There we go. How come it keeps hiding my other window? That's what I want. All right, so let's take a look at some slides here. So here's an example of a viewport. So you see here the graphics are drawn inside this window, right? But the screen itself is 1024 by 768 pixels. That's my screen. But we can't draw on that. You can only draw within the window. Now the window itself, if I look to corner, is 648 pixels wide, 668 pixels down. But I can't draw wherever I want in the window. You're not allowed to draw up here over Hello World. You're not allowed to draw over this edge. You can only draw inside. So my viewport, my drawable region, is just the yellow spot here, 640 by 640 pixels. I can't draw anywhere else. That is my viewport. Now this viewport has a standard processing coordinate system. The origin's at the top, X goes to the right, Y goes down. And then the bottom right pixel is 639 by 639. This is my viewport. Oh, let's show a sketch. Cool. I actually forgot to show the other sketch of our two triangles in processing, so I'll show that now. Assuming processing is going to behave. Sketch 1. Here we go. That did not work. Let's try that. Ha! Cool. All right, so here's my sketch of the blue and red triangles on the screen. And as I said before, let's forget about this command for now until we learn more about graphics later. Here's how it looks. This is my blue and red triangles. Pretty cool. But here, look, here's the viewport we're drawing in. Now, what I wanted to show was sketch 2. There we go. Okay. So here's sketch 2. And now what we've done is we're using the processing coordinate system. So in comparison to the other example we gave, the pixel coordinates are different. This XY is the top corner, X 320 is to the right. So if I look at this, it works. But because we're using a different viewport, we're using a different coordinate system, I have to use different numbers than the other example that I've been giving you. So here's what sketch 2 does, sketch 1 rather, that I've talked about before. We put the coordinates in the center origin at the middle, and the X goes to the right and the Y goes up, okay? Now, that's just a coordinate system in my viewport. 1.1 comma 1's up there, minus 1 comma minus 1 is down there. In Java or processing 3D, it's different. Same graphics. Different viewport, we need different coordinate system. So up here I have my X comma Y origin, X goes this way, Y goes down, and you see, look at the pixels here, they're all different coordinates. Now for completeness, I'll show what this looks like in standard OpenGL. Unlike processing, which puts Y up there, standard OpenGL puts Y down there, right? So now we have a different coordinate system. Again, X goes this way, Y goes this way, and we have, X of 351, Y of 0. In the previous one, that was Y of 640. So these coordinate systems can get really confusing really quickly. There's not a best one. There's not a worst one. The key is you just need to know what coordinate system you're using and work within that, and understand that there is no standard. It's all based on, the library you're using and the system that you're using. Okay, and then let's just show one more sketch. Here's an example of that sketch in OpenGL coordinates. Again, we set up the coordinate system just to use those bottom left instead of the top left corner, and just by changing the numbers, we can indeed get the exact same result. Okay, so we'll stop there and we'll come back and learn a little bit more about coordinate systems.